This is the Illinois Nutrient Loss Reduction Podcast, Episode 27, A Watershed Approach to Adopting Conservation. I'm Illinois Extension's Todd Gleason. You know, there are many reasons farmers across the nation are adopting cover crops like cereal rye. Chief among these are soil and nutrient conservation. Shalimar Armstrong has been researching the topic. He started at Illinois State University and then transitioned, he says, to Purdue University in Indiana.
Originally, I started my professorate at Illinois State University in the agriculture department. I worked there for about 4.5 to 5 years, then accepted a position at Purdue, but Purdue was asking that I be, a national, have a national program. And so I was able to keep my work that I started in Illinois and to do further collaboration.
What is your research focus area?
So my research focuses on conservation practices for both for nutrients, water, and soil. In-field practices, primarily cover crops, and also for our nitrogen management, and looking at the impact of those practices on the agronomics, the bottom line of the producer, of the farmer, as far as yield, nutrient acquisition by the plants, plant crop nutrition, soil health, soil nutrient cycling. And then when you couple all of that together, you have to think about how is the economics of that farmer impacted due to the inclusion or due to that farmer adopting these in-field management practices. So we focus on, from agronomics, economics to water quality to soil health.
Because you're conducting this on a national level, are you still continuing your research in Illinois?
Certainly. I'm the lead on the project in the town of Lexington. And we've been there for about going on 7-8 years now, where we're looking at 4R nitrogen management practices coupled with the inclusion of cover crops. And we're looking at the impact of those practices on the agronomics, on economics, on the environment as far as water quality, air quality. We're looking at emissions of nitrogen to the atmosphere, greenhouse gas, and also we really study the water quality implications and ecosystem services of those practices. We've been doing that for about 7-8 years. And then I'm involved with I collaborate on a watershed scale. So we learned on a field scale, and then we, develop a watershed scale study soon after in the town of Towanda in the Lake Bloomington watershed, where we located 2 large, sub-watersheds in the Lake Bloomington watershed, where we cover crop half of the larger watershed, and we did not cover crop the other watershed, and we were looking at the impacts of mass adoption of cover crops. So we have about 500 acres of cover crops in that larger watershed. The watershed as a whole is about 1,100 acres, and so that's about half of that watershed that we're cover cropping versus a 770 acre watershed where we don't cover crop. And we're looking at the water quality because both of those watersheds drain into Money Creek, which then contributes to Lake Bloomington.
It's almost as if you have a control. What's the difference between the two? Can you see results yet?
Yeah, so on a watershed scale, we are starting to see results where we're seeing the cover crops are affecting not so much the concentration of nitrate in the tile water or tile drainage water, but it's affecting the volume of water. And so when you affect the volume of water, and volume multiplied by concentration gives you load, so we have a decreased load. And we didn't see that immediately. It took 2 or 3 years of cover cropping for that system to mature and for those differences to emerge. And so we're also seeing that the average growth of cover crop is about maybe 1,000 pounds per acre of biomass, and in that 1,000 pounds, it's an average of 30 to 50 pounds of nitrogen that's in that biomass.
Because the concentration isn't different, Is it that the biomass or the cover crop is holding water in the crop itself, or that the rooting system is allowing the soil to maintain a higher volume of water, or both, or something else?
It could be both, but primarily we think that we hypothesize that the cover crop is growing, so therefore you have transevaporation occurring, and so it's using water. It's using water for its growth, and so therefore, while doing that, it's actually it could be possibly drying out the soil, right? So you imagine if this field does not have cover crops, it would take less rain to push water through the profile in order for it to be intercepted by the tile drains, then goes to the creek, right? But if you're growing a plant, you're growing plants longer, so during more time throughout the season. So in the fallow period, you're growing a plant when you normally would not. And so now you have this plant growing in this fallow period, and it's using water. It's causing the soil to be a little drier compared to where you don't have cover crops. And so it takes more rainfall in order to create drainage, right? And so you have less of a volume of water leaving. And on top of that, now you still have the cover crop using or taking up nutrients, taking up nitrogen and holding it in its biomass, which is also critical to nutrient loss reduction, right? Because if it's in the biomass, it's not leaching, and also it's not denitrifying to the atmosphere. It's captured in the biomass to be released at some point later in time.
Can you summarize the major takeaways you believe you have so far for producers?
Yeah, so on the field scale study and at the watershed scale, we see the same trend. Where you have cover crops, you are reducing nutrient loss reduction. So you're reducing the amount of nitrogen that's leaving the field through the tile drainage. And we have seen reductions we can really be precise on the field scale and say 35 to 50% reduction in nitrogen loss. Okay, that's what we're seeing on a field scale. We can be precise there. On a watershed scale, it's more difficult to come up with that precise number, but we think it's somewhere at least 30% reduction. But it took time for that system to mature. After 2 years, we start seeing those reductions.
What other questions about cover crops and nutrient management have you been researching?
We've been looking at the agronomic side of things. And so to be truthful, we have not found all of the answers because we're studying a system that's highly difficult, where we have cereal growing prior to corn. So those are two grasses. There are a lot of antagonistic things that could occur. In fact, we recommend that you grow cereal before soybean and some other species of cover crop like radish oats or clover before corn. However, cereal is the most commonly used cover crop in the region of the Midwest and the Corn Belt. And also it does the best job with nitrogen loss reduction, right? It keeps nitrogen from leaving the field. So my research group has taken on the task of trying to understand how to make it agronomically feasible for farmers. And so we are actually starting answering a new question. How can we make corn behind cereal productive? And so we're looking at what we're calling skip row technology. So when we drill the cover crop out, the cereal prior to the corn, we drill in strips, and we're leaving a space for the corn to grow, to be planted where cereal was not planted, right? So you're talking about non-intersecting zones of growth of cereal and corn. So we're using precision agriculture that normally is just used for corn and soybeans, but we're using that same precision to plant the cereal to leave a space where the corn could be planted in the spring where cereal was not planted. And so we're doing that, and we're investigating that to determine if we are reducing some of this antagonistic relationship between cereal and corn, by planting them in non-intersecting zones across the field. And we want to see, can we get optimum yield doing that compared to the old way we planted, which was broadcast or drilled and not leaving a skip row? Do we have any negative trade-offs with the environmental ecosystem services, such as nitrogen loss reduction, when we have this skip row technology? Okay. And then, could we use less seed and get the same environmental ecosystem service and get equal or greater yield, which would be great. And so we're in our first year of studying this. I have some colleagues in SIU studying this, and we are working together across the entire state to do this, and also in Indiana.
Any particular advice from you for producers when they want to try cover crops?
Yeah, so when you think about adopting cover crops, you need to first know, what do you need in your field? So if you think about cover crops and all of the species as tools in your toolbox, what tool do you need? Erosion control because you have greater than 2% slope, or do you have flatland 0 to 2% slope, and you have tile drainage, and you want to reduce the nitrogen that's leaving? So when you understand the problem that you're trying to address, then you can select the proper cover crops. And the other thought is plan ahead. We recommend non-grass cover crops before corn until we figure things out, right? So if you're going into corn, you're coming out of corn and you're coming out of soybeans going into corn, right? You want to put something that's going to produce a low C&N ratio, carbon to nitrogen ratio biomass that releases the nitrogen quicker, less antagonistic to your corn, right? If you're going into soybeans, there's no worries. You can use cereal rye, right? And so think about your crop rotation, and you might want to rotate your cover crops with your cash crops. And think about the problem that you're trying to solve. Think about cover crops as a tool in order to help you solve those problems. And I think if you do that and plan, and tap into your resources, tap into your extension services, Midwest Cover Crop Council. If you Google that, there's decision-making tools there to allow you to select and know when to plant and know, the best timing to plant, and also know how to, if you want to do a mix, right, to get some diversity. The tools there on that website will help you determine the mixture of the ratios to mix your cover crop plant, your species.
Shalimar, it was great to talk with you. Thank you so much.
Thank you.
Shalimar Armstrong is an assistant professor at the Department of Agronomy on the West Lafayette campus of Purdue University. You've been listening to episode 27 of the Illinois Nutrient Loss Reduction Podcast. The program is produced in conjunction with Illinois Extension Watershed Outreach Associates Jennifer Woodyard-Jones and Haley Haverback-Gruber. As described in the State of Illinois Nutrient Loss Reduction Strategy, Woodyard-Jones works in phosphorus priority watersheds, and Haverback-Gruber's work is with nitrogen priority watersheds. I'm Illinois Extension's Todd Gleason.